Okay, so let's take a peek at these quick. 198 feet into rods. So using our conversion factors that we talked about, that unity fraction, we'll make it a fraction, 198 feet over 1. And then in our conversion factor, feet are going to have to go on bottom so that they'll cancel out. And of course on top, since we want to change it to rods, we're going to put in rods. What's the relationship between rods and feet? One rod is 16.5 or 16.5 feet. So the feet cancel. 198 times one rod is 198 rods. 1 times 16.5 is 16.5. Divide that out to get 12 rods. How many of you had 12 rods? Cool. Next, we'll go down here 27 millimeters into meters. Remember, this is on the chart. You got meters, decimeters, centimeters, and then millimeters. So to go from millimeters to meters, it's 1, 2, 3 spots to the left. My decimal point has to go 1, 2, 3 spots to the left. Have it add a 0. So 0.027 meters. Got her? I was going to ask. You raise your hand first. Anybody have any questions on that one? Everybody got to work? Okay. The biggest thing there is just memorizing the order of the prefixes in the metric system. And we're going to hit them when we do weight and capacity and all that good stuff. So, this is the one I put up here intentionally just to see if you guys could really understood the conversion methods. 14 hands. Going in inches. So I'm going to put 14 hands over 1. Now my conversion factor, hands have to go on bottom, inches on top. 1 hand is 4 inches. So now the hands cross cancel. 14 times 4 hands is, or 14 times 4 inches is 56 inches. 1 times 1 is 1. So 56 inches over 1 or just 56 inches. Any questions on that one? How many of you had that one right? Good deal. And then, of course, 16 inches into centimeters. 16 inches over 1. Anybody remember the relationship between inches and centimeters? You got her. 1 inch is 2.54 centimeters. Inches are going to cross cancel. We have 16 times 2.54, which is going to be what? 40.64. Is that right? Yep. How many had that one? No? Can't remember the 2.54? Okay. 2.5 would give you awful close. That puts you at 40. It's, in most cases, that's probably close enough outside of precision machining. Okay, so you guys have the idea. We're okay with those conversions. As long as you know the equivalency, like when I gave you the 1 hand equals 4 inches, you're okay making the conversion with the conversion factor or however. The biggest thing, remember, I told you, is you look at the units. If the units get smaller, then the number has to get larger. If the units get larger, then the number has to get smaller. So like going from inches to feet, the unit's getting larger, the number has to get smaller. Which only makes sense because you're not changing the amount, just the appearance. So a larger unit is going to take fewer of them. One of the applications of this that pops up is measuring lengths, measuring diameters, and all that. And I know you guys know how to do it, but I just want to go over this. When we go to measure, I'm going to start out with this line here on the right. When we go to measure a simple length, a couple of different schools of thought on how you should do it. Now, the standard way that a ruler works, if you have a steel ruler or just your regular plastic ruler or whatever, even a tape measure, is you put the 0 end of the ruler at the end of the whatever it is you're measuring. In this case, this little line. And then, of course, it's marked, numbered. And you find the number and marking on the ruler that lines up with the other end of the line. But in some cases, that's not the most accurate way to do it. A lot of times on these rulers, the ends get rounded a little bit or chipped off. In fact, some rulers now, if you look at them, 0 isn't at the end of them. 0 is actually slightly in from the end of them, which is actually done because of what we're talking about right now. Because the corners get rounded off or the ends aren't perfect, sometimes starting at 0 on your ruler isn't the most precise way to measure. Now, for you guys, if you're trying to measure really precisely, you're going to be using a caliper or a micrometer anyway. But if you are trying to use a steel ruler, a lot of times what is more accurate is to start at the 1 marking on the ruler. Yeah, I know my markings should line up, but they don't. If you start at the 1, then you know exactly where that marking is, and you can line that up with the end, and then just at the other end, you subtract 1 unit from whatever it is your reading is. So this one here is reading 4.5. This one would probably read, well, should read 5.5 if we're doing it correctly. You subtract 1 to get the actual measure of 4.5. I'm not going to pound that in because I'm going to assume you guys know how to measure. I just wanted to point out that whole idea that sometimes the 0 end of the ruler isn't the most accurate place to start. Then, of course, when we're measuring a circle, if you want to measure a diameter, you have to kind of hold one end of that ruler in place and move the other end up and down to get the largest number. You can't just, unless the center of the circle is marked, then as long as the edge of the ruler is right on that center, you're going to get the largest number. But if the center of the circle isn't marked, you have to slide that ruler back and forth and get that largest measurement. See, it might be a couple of 16ths off if you don't move it back and forth. Once you have the diameter of the circle, you can find the circumference. The circumference, of course, is just the distance around the circle, or the perimeter of the circle, if you want to call it that. Circumference of a circle is equal to the diameter of the circle times pi, or pi times the diameter. The diameter, again, being what we just measured going across. Pi, most of you should have a pi key on your calculator. It's 3.14159, or 926, blah, blah, blah. For the most part, we round it off as just 3.14. Now, for you guys, however, in precision machining, that might not be precise enough. Since a lot of what you do goes down to the nearest 10,000th of an inch, you may have to use the pi key on your calculator to make it precise enough. Now, the question is, we talked about significant digits. If we use 3.14, we do have to worry about significant digits because it's being rounded to the hundredths place. If you use the pi key on your calculator, it's assumed to have an infinite number of significant digits, so you don't have to worry about rounding. So just something to point out. For most of the time when we use pi, almost all the time when we use pi, we're going to be multiplying. So you'd have to round, if you use 3.14, whatever you did, you'd have to round to 3 significant digits. Now, I told you I'm not going to force that whole rounding and significant digit thing in here, and I'm not. I'm just pointing that out so that, in the shop, if you are calculating with circles, make sure you use that pi key on your calculator. Most of what I do in here, I am going to use 3.14 because on my little pop-up calculator here, and most of you will have to do second pi, and it's just extra keystrokes that I don't feel like doing. But there it is, 3.141592654. Anybody know how many digits pi actually goes? It goes forever, yeah. When I was in college in the math library, they had a book called The Book of Pi, and it was like 260 pages. And all it was, it started at the first page, 3.14159 for 260 pages. And of course, on the last page, it just had ... because it goes on forever. Yeah, it wasn't particularly interesting reading. But I may have skipped a few pages. So anyway, just to point that out. So if we have a circle whose diameter measures 2 3/4 inches. What'd yours come up?
I
Here, I'll come take a look. So if I put that in, 2 3/4 times pi would be the circumference. So I'm just going to put it in decimal, 2.75 times second pi. 8.63938, basically, if I round it. .63938. And since pi has no units, whatever units of the diameter measurement are the units of our circumference. That is just in inches. Let's get to work. Okay. That is those of you that have the calculator that was trying to give you the answer in terms of pi. Every time you shut it off, a lot of your calculators will default back to that math print mode. So if you forget how to change it, let me know and I'll show you. It converts it with the SD key too? Okay. Okay. Now just a little, I think we mentioned this one before, but I want to try it again. So now that we're doing this calculation here, we're doing stuff like this where we're getting 8.63938 inches. If I was, in machining, you'd just leave it like that. You'd measure to the nearest 10,000th or 100,000th of an inch. In this area, by the way, the most precision manufacturing I've seen is there's a company in Chippewa Falls that is measuring some of their tooling down to the millionth of an inch. I set up their wire EDM for them to get that precision. But anyway, let's say we're just using standard measurement, using a tape measurement. We want to know what this really is to the nearest 32nd of an inch. Remember how to do this? Yep, we're going to move the 8. We don't need the 8 because that's going to stay whole inches. 0.63938 is going to become our fraction, so we're just going to put it over 1 to make it a fraction. Now we want the denominator to be 32. Right now it's 1, so you're going to multiply by 32 on top and bottom. So on top there we have the 0.63938, so I'm going to subtract the 8. Leave just the 0.63938 and then times 32. 20.46. Now you'll notice I didn't type in 0.63938. I left it on my calculator as 0.63937 whatever. Had I put it in as 0.63938, it might have made this slightly larger. Anyway, so we got 20.46. That tells us this is between 20 30-seconds and 21 30-seconds. Which one is it closer to, 20 or 21? Yes, 20.4, so it's got to be closer to the 20. 0.46 is less than halfway. What's that? Well, you're double rounding on me there. Remember, when we're rounding, this question actually came up in one of my other classes yesterday. What you're looking at here is this is 19, 20, 21, 22. And the cutoff between the 20 and the 21 is at 0.5, 20.5. So anything less than 20.5 is closer to the 20. So that's 20.46. It is less than 0.5. It does have to round down. A lot of people want to do that. They want to look at this and say, hey, the 6 makes this a 5, and then the 5 makes this a 1. Can't do that. When you round, you only round at one position in the number. You don't start at the right end and work your way back with them. Otherwise, that does happen, that you get that happening. But true rounding is just talking about the number line. And since 0.46 is less than halfway, it stays 20. It rounds down to 20. So 20 30-seconds, which is going to reduce to 5/8. So this is 8 5/8 inches to the nearest 32nd of an inch. Now some people ask, how could you reduce that to 5/8? I thought you wanted it to the nearest 32nd. Well, 5/8 is still the nearest 32nd. It's just in a simplified or reduced form. So I want you guys to try this one. 0.314 inches, and I want it to the nearest 16th of an inch. So I'm going to get 0.314 over 1. Then what are we going to do? So we want 16ths. It's going to be times 16 over 16. So 16 on the bottom. What is that going to be? 5.024. So that's going to be pretty obvious between 5 and 6, but it's going to be 5 16ths. How about 2.979 inches to the nearest 16th? So when you multiply that one out, take the 0.979 times 16, you get 15.664. Tells us that's between 15 sixteenths and 16 sixteenths. Which one's it closer to? 16 sixteenths, which of course is 1, which means we're not going to have 2 inches. This is going to be 3 whole inches. You round up to the next whole inch. Okay, so that we can convert with these measurements, and we can, convert our decimals into nearest fractional measurements. The next step, again, this should be review for most of you, but want to go over it. Looking at adding measurements. If I have 7 feet 3 inches, and I'm going to add 4 feet 8 inches. Just like adding whole numbers or any other numbers, I'm going to start on the right and work my way back to the left in case I need to carry or borrow or whatever. Now, just like I had mentioned with whole numbers, I could start on the left and go to the right. It doesn't matter. It's just we're so used to going right to left that we're going to keep doing it that way for now. Notice, instead of lining up place values, tens, hundreds, thousands, and tenths, hundredths, and thousandths, I'm lining up units. I got inches and feet lined up with each other. So inches and inches, 3 inches and 8 inches make 11 inches. Do I carry since that's more than 10? No. With feet and inches, I only carry if I go over 12. Good. So 7 feet and 4 feet make 11 feet. So 11 feet, 11 inches. So I could have 8 feet, 10 inches plus 5 feet, 8 inches. So now I'm going to start on the right side. 10 inches plus 8 inches makes 18 inches. That now can be split into 1 foot with how many inches left? 6. Exactly like dealing with a fraction with a denominator of 12. If you think of this as being 18 over 12, 18 goes into 12 one time with 6 left over. So that 6/12 are the 6 inches. So we keep the 6 inches and we carry the 1 foot. 1 and 8 makes 9, and 5 is 14. So 14 feet, 6 inches. Not so bad? Okay. When we subtract, same thing. We're going to start at the right and work our way back to the left. 8 inches minus 6 inches is 2 inches. 9 feet minus 3 feet, 6 feet. So it's 6 feet, 2 inches. Now again, we can run into things like this. 7 feet, 3 inches minus 4 feet, 11 inches. We go to subtract. 3 minus 11, of course, can't be done, so we need to borrow. This is going to become 6 feet. This is going to be what? Yeah, plus 12 makes it 15. What we borrowed was 1 foot or 12 inches. Again, just like fractions, you got to think of it as everything's going to be 12 now. So now we're going to subtract. 15 minus 11 is 4 inches, and 6 minus 4, 2 feet. So 2 feet, 4 inches. It gets slightly more complex as we get up into the multiplication and division. Let's multiply. Let's try 7 feet, 9 inches times 5. What I'm going to do here is we're multiplying a measurement, which is the 7 feet, 9 inches, of course, by what we call a scalar or a counting number. The 5 is just saying, I need 5 of these pieces. It's not a measurement. Because it's not a measurement, again, we're not going to pound significant digits, but if we were doing work to significant digits, it doesn't count. It's considered to have an infinite number of significant digits. So whatever the other number is, we round off to whatever the other number is. So anyway, we're going to multiply just like we would with whole numbers. We're going to start on the right and work our way to the left. So 5 times 9 inches is 45 inches. That, of course, can split into how many feet? I think that's 45 out of 12. 12 goes into 45 3 times. That'd be 36 with 9 left over. So we're going to keep the 9 inches and carry the 3 feet. Now 5 times 7 is 35, plus the 3 is 38 feet. It could get a little uglier. We could have something like 4 feet, 7 1/4 inches. And let's say I need 7 of them. So now I'm going to do 7 times 7 1/4 will be what? 49, 50 3/4, right? Inches? Does that work? That, of course, can be split into feet and inches. How many feet? 12 goes into 54 times. That would be 48. So there's 2 3/4 left over. So we keep our 2 3/4 inches. Carry the 4 feet. 7 times 4. 28 plus 4 is 32 feet. How you guys doing with those? Okay. Let's do one more example. Eight feet, 3 1/2 inches times 9. So we're going to start with the 9 times 3 1/2 inches. What's 9 times 3, of course, is 27. 1/2 would be 1/2 times 9 is 4 1/2. So 27 plus 4 1/2 is, well, let's do this out the right way. 3 1/2 times 9. We would change this to 3 times 2 is 6 plus 1 is 7/2 times 9 over 1. 7 times 9 is 63 over 2. 63 divided by 2 is 31 with 1/2 left over. Okay, makes sense? So 31 1/2 inches splits into how many feet? 2 feet would be 24 inches, so how much is left over? 7 1/2. So we keep the 7 1/2 inches, carry our 2 feet. 9 times 8 feet, 72 plus 2 is 74. 74 feet, 7.5 inches. What do you think? Good stuff? Okay. Division. Division is the one operation where we start on the left and we go to the right. And it's because of this whole repeated subtraction thing. Some of you may have been taught you turn feet and inches all into inches, you divide it, and then you convert it back, which works. That works fine. But to me, it's quicker to divide it out like this. 7 goes into 23 feet. How many times? 3. That'd be 3 feet. 3 feet times 7, 21 feet. There's now 2 feet left over. Before I bring down the 4 inches, I'm going to convert that 2 feet into inches. How many inches is that? 24 inches. Now I bring down the 4, I have 28 inches. 7 goes into 28 4 times. So 23 feet 4 inches, if I cut it into 7 equal pieces, will be 3 feet 4 inches. Oh, let's see what I'll put in here. We'll see if that works. So I have something that's 20 feet 8 inches, and I want to cut it into 8 equal pieces. 8 goes into 20 feet how many times? Twice. So 2 feet times 8, 16 feet. There's 4 feet left over. What do I have to do now? Turn the 4 feet into inches, which will be 48. Bring down the 8 with the 48, 56 inches. And now my 8 goes into the 56 inches 7 times, 7 inches. So 2 feet, 7 inches. I want you to try these two on your own. If I have something that's 3 feet, 7 1/4 inches, multiply it by 6. If I need 6 of them, what's the total length I need? And then this one here, we're going to divide. I'll have this problem up here before you're done with the first. Okay, so we have 6 times 7 1/4, which is 43 1/2. Good. So we're going to split that up. How many feet can we get out of there? 3 feet would be 36. How much is left? 7 1/2. So we keep 7 1/2 inches, carry 3 feet. So now 6 times 3 feet, 18 feet, plus 3 is 21. 21 feet, 7 1/2 inches. 5 feet goes into 19 feet. 3 times, so 3 feet. 3 feet times 5 is 15. With 4 feet left over. And then 48 inches plus 7 is 55. And then 55, 5 goes into 55 11 times, so 3 feet 11 inches. How many had both of those right? Anybody not sure how we got them? You're not sure? Which one? The multiplication or the division or both?
How did you? 43.
This here?
Yeah.
So 7 1/4 times 6, right? So 7 times 4 is 28, plus 1 is 29/4. This will be times 6 over 1. We'll cross cancel the 4 and the 6, make this a 3 and a 2. 29 times 3 is 87. 2 times 1 is 2. So 87 divided by 2. 2 goes into 8 4 times with nothing left over. 2 goes into 7 3 times. That's 6 with 1 left over for 43 1/2. Yeah, I skipped a few steps there. Is that all you had on that one? Everything else makes sense? Or kind of? How about the division? No?
I mean, I get the most part. Where did you get the 40? Oh, 14.
4 feet, we had to convert it into inches before we brought down the other inches. Yep. Let's do another couple. Five feet, 10 3/4 inches times, I don't want to do 10, times 9. And then we'll do 19 feet 6 inches divided by 9.